I wanted to say hi to everybody. Thanks to joining us today. We're going to be talking about Edge AI connectivity made simple, which we're going to explain what that means. So specifically, what we're going to be doing is we're going to start by introducing you to the Blues Wireless ecosystem. We're going to talk about the stuff we bake at Blues, and more importantly, why we think we can help you solve some of your IoT problems. And then we're going to get our hands dirty. We're going to do a lab where you're actually going to get to try out the note card, see how it works. If you have a physical note card, which I've got one over here, you can use that for going through the lab, but you don't have to have anything. We actually have a simulated way of going through our quick start experience. So everybody will be able to follow along, whether you have hardware or not. And then we're going to shift gears a little bit. This is an Edge Impulse event. So we're going to look at using the note card along with some ML processes and build some ML projects. And then I've got a lab at the end that's going to show off how all of that works with a little bit of accelerometer data. That second lab, you do need hardware for. It was in the description of the event, but if you don't have anything, don't worry about it. I'm going to show things off. I think sometimes it's a fun one to just watch and see how it works and see how you can apply it to other projects that you might want to build with Edge Impulse and Blues. And speaking of which, we being Edge Impulse and Blues, are excited to announce, as of today, a contest that we are unveiling for building cool apps with Blues and Edge Impulse together. And we're giving away $5,000 in prizes, a couple PlayStation 5s, some other cool stuff as well. So if you're interested in this, make sure to check it out. I'll drop the URL in the chat in a bit here. And we've also got it, the URL I've got up at the end, so I can make sure you get it. But the good news for you is that you're in the perfect place to learn about Edge and Blues together. So pay attention during this session and you'll be set up, you'll be in the driver's seat for winning the contest, winning your next PlayStation 5. All right, so I want to start by just giving you a brief intro. What is Blues? Why you should care? We'll take a few minutes of that, and then we're going to actually see it in action by going through a lab. Now, whenever I talk about Blues, I like to start with this quote. It's from our CEO and founder, Ray Ozzie. You may not recognize Ray's name. He was one of the first people involved with Azure and was also behind Lotus Notes and some other projects as well. But I love this quote. The quote is that complexity kills, sucks the life out of developers, makes products difficult to plan, build, and test. Now, this is something I felt to my core is 15 years of doing software, hardware development. But I would argue this is especially true when it comes to the Internet of Things. When you want to build something for the IoT, you all of a sudden have all these decisions to make. What device am I going to use? How am I going to talk to a network? Am I doing cellular or Wi-Fi? How am I going to power this? How is all this going to work? There is a lot. So at Blues, our aim is to try to make wireless IoT easier to developers and more affordable for all. And the main way we do that is through the note card. Now, the note card is our low power system on module. I've got one here. It's about 30 by 35 millimeters. And essentially, it's a little system that can do both global cellular and GPS. The black one, which I've got over here, does Wi-Fi as well. We're going to be focusing on the cellular one, the green one here today. And the cool thing about the note card is you get global cellular in this package, and it comes with 500 megs of data and 10 years of service baked in. So you don't have to worry about, you don't have to bring your own mobile plan. There's no SIM card that you have to bring. All is just sort of embedded and packaged within the note card. And not only that, the note card also speaks JSON. So if you've ever had the displeasure of working with a cellular modem before, you may know it uses some pretty archaic syntax. It's not easy to use with, to work with. With the note card, everything is JSON. So you're sending data over cellular under the hood, but you're working with very simple JSON APIs. And we have SDKs that make it really easy to send that JSON. So if your preferred environment is Python, Go, Arduino, C, C++, we have some other community-built ones as well. We make it really easy to interface with a note card and to work with cellular data. So that's the note card. And actually, I like to think about the benefits of the note card by talking about what you don't need if you use the note card. So first of all, you don't need your own SIM card or separate mobile plan. There's no subscription involved with the note card. Everything is just baked in. Again, you don't have to manually connect to a modem. You don't have to worry about security. The note card knows where to send data to out of the box, and we're going to look at how that works in a minute. You don't have to worry about power management. The note card is very low power friendly by default, to the tune of this thing actually uses 8 microamps when idle. So if you need to build an ML app that's running off battery, the Notecard can make it really easy to add communication to those types of applications. And so that is the Notecard. That's basically what this looks like. It's basically just a little system that makes it really easy to do cellular and also GPS. Now, to make it easier to test with the Notecard, actually the Notecard has this M2 edge connector on the bottom of it that you can embed into pretty much any IoT project. But to make it easier, we make these developer boards that we call note carriers. So note carriers are basically boards that accept a Notecard. So for example, I've got like one here, accept a Notecard, and then have a number of features like JST connectors for attaching LiPo batteries or solar, attaching quick connectors. There's a micro USB slot for either supplying power or communicating with the Notecard. The note carrier F, which is the second one down there, it looks pretty similar, but it also has feather compatible header sockets. So you can take a feather-based MCU, use that around the Notecard, and that's actually what we're going to be doing in our second lab that we're going to be doing later on today. So Notecard makes cellular easy. Note carrier makes it really easy to sort of get up and running with a Notecard. And the final piece of the puzzle when it comes to the Blues ecosystem is NoteHub. NoteHub being our cloud service that the Notecard knows how to send data to out of the box. So Notecard accepts your data from the Notecard and makes it really easy to route your data to any cloud application you'd like. So you can take your data and easily route it to like a big cloud like AWS or Azure, or to your own HTTP server, or to some sort of dashboarding platform, and easily get your data from your sensors, your host, your microcontroller, all the way up to your end cloud of choice. NoteHub also has features for more like enterprise-y features or bigger deployment features like managing fleets of devices and doing things like updating firmware on note cards over the air, which is really cool. And we'll look at an example of later as well. And also everything through NoteHub is securely communicated. The Notecard actually communicates with NoteHub off the public internet through a secure VLAN. So kind of slick. And so if security is important to you, the Notecard is a great choice for that as well. Now, I want to show just quickly put all of those pieces together and just give you the flow of what using the Notecard actually looks like. So what we expect you to do is take your own microcontroller, your own single board computer, your sensors, whatever it is you happen to be building or working with, and to use that to send JSON to the Notecard. So this is where we provide SDKs for a number of platforms to make this easy. But you can see as an example here, I'm taking a note.add JSON request. I'm taking a temperature that I'm getting from my own sensor. I'm formatting this up and I'm sending it to the Notecard. The Notecard then takes that data and securely transmits it to NoteHub, which NoteHub can then take that and transfer it to your own cloud. So really, the Notecard is making it simple to take your data, whatever it may be, from your host, your setup, and easily get it to your cloud. The process also works in reverse. So you can also take data or information or commands from your cloud and push it all the way back down to the Notecard and ultimately to your host. This is nice if you want to do any sort of remote control types of scenarios. I want to send a command to tell my robot to move right. So I send that command down to the Notecard. The Notecard sends it to my host. My host tells the robot or a servo or whatever to move right. And I have this ability to remote control things, turn buttons on and off, whatever the case may be, or whatever I want to do. So Notecard makes that simple. The last thing I want to do before we actually take a look at what this looks like is talk about when the Notecard does make sense. Because the Notecard, I mean, we think the Notecard is pretty awesome. It solves a lot of problems, but that doesn't mean it's sort of a silver bullet that's going to solve all of your IoT problems. The Notecard makes the most sense whenever you're working with low bandwidth cellular. So I have some sensor data, I have some location data, I have some ML inferencing data, and I need to send that up to the cloud. The Notecard is an amazing choice for doing that. The Notecard also works really well in edge computing scenarios, and which is some of what we're going to be looking at today. So I need to do some compute process on my host. I need to run some data through some ML model, but then I need to send the results of that up to the cloud. The Notecard is excellent for that sort of thing as well. Again, the Notecard is excellent for secure communications. And really, anytime you need to get data from a local IoT device up to the cloud really, really easily, Notecard fits into that situation really well. But like I said, that doesn't mean the Notecard is perfect for everything. The Notecard is not a Wi-Fi replacement. It's not going to give you sub-millisecond latency. We are sending data up to cell towers, so there is some latency that's just sort of inherent to that process. And so really any sort of high bandwidth thing is not the greatest fit for the note card. You're not going to want to do any sort of streaming, especially video streaming on a note card as well. All right, so that is the whirlwind tour of what the note card is. But I think it's a little bit easier to see this in practice. And we have a lab where we can show you off not just how the note card works, but you can actually go through this yourself. And to do that, I'm going to stop sharing my screen and I'm going to turn things over to Paige because she's going to show this off. And I'm going to switch my video to my camera too, or my desk, so I can show off some of the hardware as well. But Paige, I'll let you take it from here.
Awesome. Thanks, TJ. So as TJ said, we're going to go through a lab where you'll get to actually interact with the note card and see exactly how Blues hardware works. But before we do, let's give you a quick rundown of the pieces that we're going to be working with today. So as TJ is showing, and as I am showing as well, the first and most important key piece of this is actually the note card itself. This is our 30 by 35 millimeter system on module. And as you can see at the bottom, this M2 connector is how we can embed this into any IoT application and any existing project that you might have. Second up is the note carrier itself that we're going to be using. I have got the note carrier F today because, as TJ mentioned, it has the feather connector at the bottom, which, while it's not necessary for our initial demo, it will be necessary once we get to the edge impulse portion of the demo today. So as you can see, we have 3 JST connectors on one side. It's got LiPo, it's got solar, and it's got a V+ option. We have quick connectors on the other side, so you can plug in any peripheral sensors that you might have. We have a micro USB plug. Then this is used for both powering the note carrier as well as for connecting and communicating with the note card through your computer. And of course, we have the M2 connector right in the center, which is where you can slot the note card in for easy access. So the last portion of our puzzle is the dual cellular and GPS antenna. And this actually is how the note card itself will do both cellular connectivity as well as GPS location. So you can attach it right to the note card itself and you're ready to go. And with that, we are going to actually get to the demo portion. And to save you from having to watch me try and assemble this in real time, I have a previously constructed note carrier, note card, antenna, and I've also plugged in the Swan, which is our MCU that Blues Wireless makes, just in case you're ready to get started with that as well. And all of this is available in the Blues shop as one kit, which is known as the Blues Feather Kit for Swan. So if you're interested after the demo in purchasing this, you can buy it all as one and be ready to go. So with that, let's go ahead and plug in our note carrier, if you have one, to your computer. Plug it in via the micro USB. You can see that the note card is already blinking and getting ready to go. And we're going to go over to the quick start and get started.
If you are going to buy a starter kit, wait till the end because we have a discount code on the last slide. So make sure you stick around for that.
Exactly. All right. So I am going to share my screen. And if you're following along, the first place that you're going to want to head over to is dev.blues.io. So this is our hub for all things Blues Wireless, and it has some great quick starts for not just the note card, but also our Swan, which is our MCU, and some of our newer products that we're coming out with like Sparrow. But the one that you'll want to click on is Quick Start, and then you're going to select the note card and the note carrier. So as I just showed you, if you're following along with hardware, you have the option of selecting the note card and then the note carrier prototyping board that you might be using. However, if you don't have hardware yet, we also have the new note card simulator, which is a virtual interactive note card, so you can follow along with us without having the actual hardware. So if you don't have it available, go ahead and click on a note card simulator, and if you do, select the note card and the note carrier of your choice, and then you'll go ahead and click on USB note card and select paired, You'll have to do this on either a Chromium-based browser, so Edge or Chrome would be a good option because we actually use the Web Serial API for this. And go ahead and connect. And now you can see that if you've connected successfully, we have a few little note card information. So connected serial, our device ID, and the firmware that this particular note card is running. So if we scroll down, we're going to go past some of the outbound and inbound communication that TJ showed between the note card and Note Hub, which is our out-of-the-box, cloud-based, secure place that the note card will send its data to. We'll scroll past the setup instructions, and we'll get to the first portion of this, which is actually connecting to the note card. So if you come here and click the try button, it will print rec.card.version into the browser or into our note card web REPL. And if you go ahead and click enter, we get a little information about this particular note card. So you can see the firmware that it's running, you can see the device ID, and you can see the particular note card, as we have different note cards for different parts of the world where cellular requirements are different. And that's great. That shows us some JSON. It shows us how you can connect to the note card. But what you really want to see is how do I send data from my IoT device to Note Hub, which is where all of this data will be stored. How does the note card do that? And that's what we're going to do next. So if you head over to notehub.io, that is our cloud, and you can set up a free account. It's free for anybody to use to get started. And once you have set up your account, you can go ahead and create a project. And this is how we're going to tell the note card that this is the place that you should send all of your data once it's received. So I'm going to give my project a name of Edge Impulse Imagine, because that's the webinar that we're doing today. Hit create the project, and in a few seconds, we should have a brand new project that we can use. Okay, so before we head back over to the quick start, go ahead and copy the project UID, the product UID, because we're going to need this to connect our note card to our project here in Note Hub. So now if we head back over to the Blues Quick Start, we can scroll past the setting up Note Hub portion, and we can get to setting up our note card. So again, you're going to hit the try button, but instead of doing hub.set and then product of some company, this is where you're going to paste in your actual project. So go ahead and replace that. And if all goes well, you will get this empty curly braces at the bottom. And then we're going to actually sync it, because as TJ said earlier, the note card is designed to be ultra low power. So syncing immediately is something that you would have to enable if you wanted it to happen. Otherwise, it's usually set to some sort of an interval so that the note card will conserve power. It will queue up new events, and then at some predefined interval, it will send them to Note Hub to save on battery life and data. So go ahead and click this hub.sync request and hit enter. And if we head back over to Note Hub now, we should be able to see that our device is now there, and there it is. So our note card is now connected to Note Hub, and it is ready for any new environment information that we may be getting for events or for, whatever your devices are recording in terms of sensor data. It's going to send it here. So that's fantastic. So you've seen that's how to initially connect your note card to Note Hub. Now let's talk a little bit more about actually sending sensor data and sending notes, as we call them, to Note Hub. So you'll probably have some sensors, some peripherals with quick connectors that are generating real data, but for the purposes of this quick start, we're going to give you some hard-coded data that you can send, and then we can verify that it's actually there. So for this very first one, go ahead and click the try button again. And this will create a new note. And this is what all of our sensor data gets sent as. So we have a body. This one has a temperature and a humidity reading. So go ahead and click the enter button, and you'll see that it says total of 1. Now, this hasn't actually synced to Note Hub yet. Instead, it is queued up and it is ready to go. And we will have to initiate a hub.sync, just like we did to initially connect our note card to NoteHub, to have NoteHub receive this data. So once again, if we scroll a little bit further down, we have that hub.sync request. We can hit enter, and we will see that we get back the empty curly braces, which means that it is being sent to NoteHub as we speak. And if we head back over to NoteHub and go to our events tab, and we take a quick look, we can see, if I scroll down a little bit, we have our very first data.qo event. And there's our humidity, there's our temperature. It's just there. Pretty slick. So we've looked at how to view some initial events on NoteHub. We've seen how to add notes to the note card and then sync them to NoteHub. And as TJ said, and we'll show you sooner rather than later, there's also the ability to send information from NoteHub down to the note card. It's a bi-directional data flow, and it's pretty cool. It's really easy to use. As TJ said, it's JSON commands mostly. So if you're familiar with JSON, you're already ready to use the note card and NoteHub. And with that, I think I will turn it back over to TJ and let him continue on. And if you have any questions or you're interested in learning more about this, I would highly recommend that you go through the quick starts, because they'll really give you a solid foundation in how Blues Wireless works. And then you can start getting creative from there.
Awesome. And David, actually, why don't we take a minute to, because there's quite a few questions that have been coming in. So I think we could maybe take a minute to answer some of those before waiting for the end, just make sure people are all on the same page at this point.
Yeah, definitely. So I'll kind of read them through. To start from A, B, combining a few of these, does the module support NB-IoT or LTE-M? And what format does the note card use to send data to NoteHub? Basically, what protocol?
Yeah, so it's I actually don't know. So for the first one, you can buy both narrowband and wideband note cards. So if you go to our shop and you check it out, you'll see there's different varieties. There are also different varieties for different areas. So there's one that's more global, that's designed to work on a bunch of different cell towers in a bunch of different countries. And there are some that are oriented more to specific regions, like North American ones. So we simplified things a little bit here to keep it simple, but there are different variations depending on where you're going to be deploying the note cards and what you might want to do. Format-wise, I'm not sure under the hood exactly how it's sending the data to NoteHub. So I'll have to follow up on that one.
Great, thanks. And then from Nico, what does, on the pricing side, what does additional data cost after the plan has been used up? What does the renewal after 10 years look like?
So the renewal, you can add additional data. I believe the rate is, I'll look it up in the website in a minute and I can type it in for you, but it's like a couple dollars to add on like 100 megs after the fact that you can top it up on. I will say though, like we actually get this question a lot, and the number of customers that actually use up their data is very small, because 500 megabytes of data for an IoT project is actually like way more than you think it is. Like unless you are really, really streaming data like crazy, if you're just sending like sensor readings, location readings, even like inferencing stuff, that 500 megs will last you a very, very long time.
Mm-hmm. And TJ, to add on to that, because I can look up the website, it's 150 megabytes. You can get that for $475 US. So if you need to add on, it's very economical.
Awesome. And then from AB, does the note card also have processing capability, or is it purely a comms module?
It is not a general purpose processor. That's it. So you would use the note card in conjunction, which we're going to show in a minute here, in conjunction with a microcontroller that can do that sort of thing.
Yeah. That's where something like the Swan, the Raspberry Pi, or any of the other microcontrollers that you're used to would come in.
Awesome. And then from Nico, is the note card, do you have compatibility with the M2 micro mod board from SparkFun? by any chance?
Ooh, not yet, but I have a prototype on my desk back there.
Oh, nice.
So
Awesome.
stay tuned.
Coming soon.
It's in my desk. So
cool. And then from Justin, does the note carrier have a charge controller for solar? Does it have a charge controller on it? So solar can charge the LiPo, or USB charging for the LiPo?
Yes, so it will be charged once you've plugged in a LiPo battery and you're also plugged in either to solar or to a micro USB. It will charge the LiPo as well.
Awesome. And then the last one for this round, is the device field shown? Is the device field shown in the JSON equivalent to the serial number?
Yes.
Okay.
yeah,
Awesome.
that's a short answer.
Yeah. Great. So yeah, definitely keep adding questions, but I'll hand it back over to y'all just to keep things moving through.
Yep. Good stuff. Paige, I think I need, well, can I take over screen sharing, or do you need to take yours down first? Yeah, I think I need you to take yours down so I can bring mine up, and we will switch over.
How do I take mine down?
It's usually like a red stop screen or stop sharing button somewhere in Zoom, but Zoom likes to like make it float in a weird area. So I've always thought that weird as well. All right, so at this point, you've gotten a little bit of a better idea of what the note card is. And I think like even I've been through that tutorial many times, but I still think it's really cool just how easy it makes it. Cellular, at least when I started at Blues, I always viewed cellular as this like mythical, like hard, complex process. And the fact that you can send like simple JSON commands to send data over cellular has always felt really magical to me. But I want to move on and talk about some machine learning stuff, because this is Edge Impulse Imagine. This is a machine learning event. And let's talk about how the note card can actually help you in these like machine learning types of applications. And we being Blues and both Edge Impulse, think that our technologies work really well together or in combination. And we partially think that because we've built a lot of stuff using our technologies together, both ourselves, our communities, the greater sort of tech world has built a lot of really cool stuff. And in fact, if you're getting bored of us and just want to multitask, you could just Google Hackster, Blues, Edge Impulse, and you can find a lot of cool projects, a lot of cool write-ups that use the two technologies together. But I wanted to paint a little bit of a picture. I wanted to just pick one out so you can get a sort of representative example of what a project like this looks like. So my personal favorite on this list is a project that I actually didn't build, but our coworker, Rob Lauer, built. He built a machine learning powered speed trap. Essentially, he was in the old man mood of getting sick of cars driving too fast down his street. And so what he did is he took a Raspberry Pi and a Pi camera, and through a camera feed captured a bunch of images, and then built a model in Edge Impulse to detect when a car was present. And then when he detected a car using Edge Impulse, he used this radar sensor up here to essentially clock how fast that car was going down his road, and then use the note card, which is in here, to send the results of that so that he could basically have a live dashboard of how many cars are going down his road, how fast they're going, the highest speed, these sorts of things as well, which I think is really, really cool and fun, both in the sense of, it's just kind of a cool thing to build, but also you could see how this sort of application would be really interesting to like city planners, law enforcement that might want to sort of monitor traffic around an area, and how the two technologies, Edge Impulse for handling the ML stuff and Blues for handling the data transport, can be really powerful together. And I think there's a couple reasons why apps like this are really powerful, and I'm calling it, as in like the name of the session too, ML inferencing, which is just the process of processing an ML model, but doing it in the Internet of Things, doing it on basically like a Raspberry Pi like Rob did, or some sort of microcontroller. This is a really powerful option because it does a couple of different things. It first of all cuts down on the volume of data that you're working with. So given Rob's example, one approach he could have taken is he could have streamed essentially a video feed of his street up to some server, which did some inferencing. It could probably do it a lot faster in the cloud, but think of just how much more data, how much more bandwidth he would have to use, how much more cloud storage he would need to make that sort of thing happen. If you do the actual ML processing on a little microcontroller like this, you only have to send essentially the results of your inferencing up to your cloud, which cuts down on that bandwidth fairly considerably. It's also a lot faster. Just the very nature of you're doing the inferencing, the actual processing of an ML model just on the edge locally just means it's just by physics going to happen a lot faster. And it also is a lot more privacy friendly as well. Rob's neighbors would probably not love if he was streaming a video feed of just a street in their neighborhood up to the web, up to his cloud. But if he's just sending metadata, that removes a lot of the privacy considerations for deploying that type of an application. And of course, this is an Edge Impulse event, so you might not already know that Edge Impulse makes the actual ML process of this really, really simple. It makes it really easy to not only collect test data, so like in Rob's example, get a bunch of pictures of cars going down his road, but also the categorizing of that data, the building of the models, deploying those models out to a device, and then continuously, iteratively, continuing to develop that model, improving it, getting it back out to a device, and working with it as well. And I think that all of this is easier to see if you see it in action. So I have a demo that I want to show you today. Now, this demo does require some hardware, and I'm going to show you exactly what I'm doing, though. So to start, if you go to dev.blues.io, which is the same place we were at for the quick start, you can head to the Swan's documentation. Now, the Swan is a microcontroller. We make it Blues. It is a Feather-compatible MCU. It's got an STM32 chip in it. There's a picture of it here. We also built it. It's pretty beefy. It has quite a bit of RAM. So it's really well suited for these sort of ML types of applications. We need to do some model processing on it as well. And you'll see that in the Swan, we have this tutorial on using the Swan with Edge Impulse. And this is the lab I'm going to be walking all of you through today. Now, the hardware you need to make this happen, you again need the, we'll go to the shop so I can actually just show this real quick. You will need a Feather starter kit for the Swan. Now, this comes with a note carrier F, with a note card, and a Swan, and the antenna. And the other piece of equipment you're going to need is some sort of accelerometer. So what we're going to build here today is we're going to pretend we're building the next great toy that we're going to put on the market. We're building a magic wand. We're going to have an accelerometer. And we're going to teach this accelerometer different gestures. We're going to teach it a chop, maybe some other things as well. And we're going to put this out in the market. Kids are going to buy it up like crazy. We're going to make millions. That is the general idea. If anything, maybe we won't make billions, but at least we'll learn a little bit about Edge Impulse and Blues Wireless along the way. So that is the hardware you need. I'm going to switch to my other camera real quick so that you can just at least see the setup I have. And it's actually not this one, too much junk on my desk, but this one as well. So this is the same exact setup that Paige had earlier. So we've got the note carrier F, we've got the note card, and that Swan microcontroller is plugged right in alongside the note card. This is actually my personal preferred way of using the note card, because somebody asked earlier, is the note card like a general computing device? And it is not. But the Swan works really well at this. And the note carrier F provides a really, really convenient way for the Swan to just talk to the note card. And we're going to look at how to do that here in a second. And the only addition from what Paige had is this guy here. This is the Adafruit accelerometer that you can get from this link. It is a $5 piece of equipment, and it's hooked up through this quick cable right here. So that's what we're going to be building with today. And essentially the gestures you're going to pretend that this is all like tucked into a nice wand that we can, do cool things with. That bit though is left up to your imagination a little bit. All right, so we're going to bring our screen back up. And that's the full setup in terms of hardware. From a software perspective, you need a few things as well. So the first is the Edge Impulse CLI. So if you are completely new to Edge Impulse, you'll need to have their CLI, because we're going to be doing some things with that. And you can get that through npm by npm installing. And then you're going to need an environment that you can use to write code on the Swan with. So you can either use the Arduino IDE or Platform IO. We are pretty big fans of Platform IO, so that's what I'm going to be using today. And I'm going to drag it over Apparently I'm clicking on their blog post, but I'm going to drag over Platform IO. And part of the reason we like it is it nicely integrates into Visual Studio Code. It's an extension, so you can just get it from their extensions menu. And it makes the whole process of pushing code to microcontrollers and getting logs from microcontrollers really, really simple. And it just integrates super nicely into VS Code. So we're pretty big fans of it. So if you have this up, the last bit of setup, and then we're going to get busy actually building out our magic wand, is configuring the swan in this quick start. So if I go here, all I'm going to need to do here is two different things. The first is it's going to show me how to install Platform IO, which we already did. And it'll also show you how to create a new project. So we can create whatever project here. In the board, it already knows about the swan. So you just type in the swan. For a framework, we're going to be working with Arduino. You can put this wherever you would like to go. When you first run this, this will take probably about a full minute because it's basically downloading all the dependencies it needs to build an Arduino application for the swan. So because of that, I built this app already and I have it ready to go, so we don't have to sit through that. But that's the entire process of building your starting application. And then the second thing you need is just a little bit of configuration here. This is just specific to the swan to make sure it's going to work correctly. And your project will have this platform INI file that needs this information, which you can see I already put in. The one bit of difference here is for an upload protocol, you can either put it in DFU or use an ST-Link Mini debugger. On our shop, it shows up as optional. So when you buy this, you can additionally, somewhere in here, I might be looking at the wrong thing. Yeah, here we go, add-ons. So you can add on an ST-Link debugger. I like it because it makes it a little bit easier to push code out to the swan. Because if not, you have to, every time you want to put code up to the swan, you have to put it into bootloader mode, which is somewhere in here. Yeah, so there's two buttons on the swan. And you have to press the buttons in a specific combination to put the swan into bootloader mode and then to upload code to the swan. But if you hook up an ST-Link to the swan as well, you can sort of skip that step. So I have an ST-Link on me over here that I'm going to be using to push code up to the swan. And that's sort of what I'd recommend, especially if you're doing any sort of serious development, having a little $15 tool or whatever that makes your life easier, personally, I think is worth it. But that is the full setup. And so if you're at this point, you now have the ability to push out code to the swan. And so to start, the very first thing this tutorial is going to have us do is just put in some starting values that is just going to read from the accelerometer. So essentially, this is a library that's from Adafruit that's connecting to that accelerometer that I have hooked up here. And then in a loop, I'm just going to be getting the X, Y, and Z values off of this. So we're just going to start as a baseline, make sure our accelerometer is working. We just want to see data coming into our log. So to do that, I'm going to hook up my ST-Link. So I got USB into the ST-Link. And then this part, got to pick up the correct swan here. This part goes into, and I might have to move this to my other desk. We'll see how well I can get it to focus, but you can see the pins on the top of the swan. That's where the ST-Link plugs into if you're using that. Otherwise, you would just plug a USB directly into the swan on the side. And then I'm also going to give the swan USB power as well. So I have two different USB cords. The second one is just going to power the swan, and it's also going to let me access the logs because I need that serial connection to actually view the logs. So I've got the ST-Link hooked up to the swan. I've got USB power going into the swan as well. So I have two different USB cords heading in there. And then once I do that, I can use Platform IO to actually push code out to my MCU, to the swan. And I can do so either through these buttons that are on the bottom that Platform IO provides. I actually like the shortcut that's built into VS Code. It's Command-Shift-P on Mac, and I believe it is Control-Shift-P on Windows. Somebody can correct me on that if I'm wrong, but this keyboard shortcut, it'll bring up different commands that you can run. And in this case, I want to upload code over to my swan. Platform IO takes care of all the hard parts of things here, which is why we like doing it. I don't have to worry about any of the compilation details. It does the magic. It pushes the code out to my swan, and then I can open a serial monitor, and I can see this absolute mess of accelerometer data coming through, which is a good way to just verify everything's working. And you can also, like, once you have this up, you can also take your accelerometer and, like, you know, have fun with it. And you just see patterns in here to make sure it's working correctly. I also like showing this because I think this is another reason, like, because what we're going to do in a minute, right? We're going to train a machine learning model to recognize patterns in this data. And I like this as an example of, like, if I didn't do the inferencing on my Swan or on my local device, I would have to stream this data up to the cloud, right? And streaming that much data will go through 500 megabytes at some point, because that's just a waterfall of data coming through. All right, so we got X, Y, and Z values. We got them coming up, but we want to do something interesting with this, right? And this is where, like, the value of edge impulse really comes in handy to me, because I just think, like, naively, if I were to try to write some sort of algorithm to find patterns in this, right, like, I would spend the rest of my life on it. There's no way I could make any sense of this whatsoever. But edge impulse makes this kind of easy. So for the next step, we're going to look at how to get this data up into edge impulse. So if you haven't before, you will need to have an edge impulse account and to create a new project. I, again, built one up here to save us a little bit of time. I called it Excel testing for accelerometer testing. And then once you have a project, you can run this edge impulse data forwarder. And this is coming from the edge impulse CLI that we npm installed to start this off. So I will kill this and this as well. And we'll start up a new terminal. This is actually why I like Platform IO, because I can just quickly, like, do all of this. I have my terminal right here. I've got everything I need. I'll run the data forwarder. It's going to start up this. I tell it which I'm going to run. I just happen to know that this one is my Swan and not the ST link. So I will do this. And it's going to look for basically a data pattern that's coming out of the serial port. And the first time you run this, and the tutorial will help you do this, it's going to say, oh, I'm seeing 3 different values coming up here. What do you want me to call them? And so the tutorial will tell you to type in X, Y, and Z. That's a pretty common pattern for working with accelerometer data. I did this once when I practiced it, so Edge Impulse was smart enough to remember that. So it already knows that it is connected, and it's telling me, hey, we're ready to go. So why don't you go here to build your model? So once again, I like VS Code. I can command or control click on the link, open this thing up in my browser. And then what I can do is I can just record new data for a brand new machine learning model right here, right in the browser with everything set up. So for example, if I wanted to start teaching gestures to my wand, because remember, we're building a wand that can do separate things. But to start, let's just try to build a state to capture what the accelerometer looks like when it is completely idle, when nothing is happening. So I can do that. And if I click this button, and this is another part that I think is just kind of magical, Edge Impulse basically is smart enough to know, hey, I'm connected to this device. So I can tell this process running on my terminal to capture essentially a representative sample of that data that's coming in through the serial connection, and then stream that data up to Edge Impulse to get a representative sample. So what happened is this just took 10 seconds of data from the accelerometer. I can view it in this chart down here. And it also saved this off as a chunk that I can use for testing and building a machine learning model. So I have idle here. It is 10 seconds. The other, we could spend the next hour building these things. I want to at least have 2 of these. So you'll see that I've also been practicing a chop. It's a very, very technical one here. And so if I want to get a sample of a chop, what I can do is start this. And then if you see on my camera, I'm like doing like a tomahawk chop, like Atlanta Braves style on here, which I'm going to have to hold up for 10 seconds. And I get some more data. It looks a little choppier, right? There's a lot more noise coming in from the accelerometer, which is what I want. Because ultimately, what I'm doing here is I'm getting enough data so that I have a pretty good sampling so that Edge Impulse is able to take completely new readings, right? Readings of accelerometer data it's never seen before, and see if it matches any of these patterns that we've set up. Now, there's a real science to how much data you need to make these things possible. And I'm sure there's great sessions you can go to at this event that can teach you a little bit more of like exactly how much data you need and different patterns and how you break things up. For me, at least with accelerometer data, I need to be getting like a solid 50, 100 different samples in there before it starts working really consistently for me. Because the accelerometer, if you think about it, like even when it's idle, it might be idle in different ways, right? You might have it set on one side versus the other or upside down. Your chop might work a little bit differently. Like somebody might chop this way, might chop this way. And to a computer, that data is going to look quite a bit different. So you need a good amount of data before this thing is really robust. But if you're just doing like, I just want to just sort of make a proof of concept, see how this works. Edge Impulse surprises me in just how quickly you can build something that works pretty decently in just a handful of minutes. Like even for my testing runs here of having like 2 some minutes of data, I think we'll find this thing is not great, but like decent at picking up different gestures that we're doing. So basically, the cool thing here is that just directly using the hardware that that's going to be like the end deployment situation for this application, we've already got a good amount of data and we were able to capture this really, really easily. It's another benefit of Edge Impulse, like manually capturing this data would have been a giant pain, but I've already got a decent amount. And next, what the tutorial will have you do, and you might be familiar with this if you are at Edge Impulse Pro, is actually build your impulses or essentially your models from this data that you have captured. And actually, there's a lot you can do here to customize, as sort of evidenced by the different things you can do, different processing blocks, different learning blocks as well. For this, kind of keeping with the theme of keeping things simple just for learning the most basic points, really all you need to do, and I'm going to find the screenshot so I know the right thing, is that when you add a processing block, you want to pick spectral analysis, because that is, as the text from Edge Impulse says, great for analyzing repetitive motion, such as data from accelerometers. So it's a nice sort of default that's built in to help you work with accelerometer data. And then you can accept the defaults for essentially everything else and save off that impulse. So that's exactly what I'm going to do. And then there's a couple different steps to basically train this model for the data that you are using. So if I wanted to generate features and see exactly how this works, and again, not being the greatest expert on the ML parts of this, one thing I do know is you typically want to see good separation between the features that you are creating. You don't want a situation where the model is basically confused as to, well, wait, is this gesture or this gesture? It's a good sign when you have really clear separations of the different features that you are trying to create, which in this case, we do pretty good. That's why we were starting with a simple demo, chop and idle. This would get a lot harder if we started to introduce gestures that were fairly similar to each other. Like if we're building like a full-on Harry Potter wand and we're supporting a lot of gestures that are pretty similar, this could get a lot trickier. But for chop and idle, it's not that hard to get some pretty clear separation from here. And then from there, the last step to building an actual model that we can deploy out to a device is to go to this classifier section and to train up the model to get it sort of ready to go. And this is going to do a little bit more work. This is, again, something that you could probably learn more about at something that focuses more on this. What I want to do is, once we have the model, show you how easy it is to get the model out onto a device. And then we're going to hook up a note card to this and look at how to get sort of data up to a cloud dashboard. And then we also have some features where we can look at some fun ways you can actually update this model on the device as well. So when this is done, we'll have a model that we can actually test on the device and that we can deploy to it. So we'll give this a minute to finish while it's building this. You'll see that the next step in the tutorial is to run through these steps. And then when you have it, you can actually test the model that you have built on your device itself with the live classification system that's built into Edge Impulse. So this is finished. It looks like the model is not very accurate at all, so I must have screwed something up. Maybe I mislabeled something, but we'll see. We'll see how it goes. Let's do a live classification. So one thing you can do is, with this same data forwarder that we used earlier to capture test data, you can actually use it to test models that exist as well. So I'm going to connect my device back up. So in the live classification section, I'm connected to my device. I'm saying I've got a sensor with 3 axes. And what I can do is the same process of connecting to this device and taking a sample. But this time, instead of sort of registering that data as test data that's used to build up a model, instead, it's going to do a live classification of it and see whether our data is working correctly. So it did this, and our idle state is at least working pretty well. So I didn't touch the accelerometer there, and it correctly thought that during the entire process, it was in an idle state. So we can try this again. We can start sampling, and this time you're gonna see me do the 10 seconds of chopping again, and we'll see if we can correctly classify this as a chop. And regardless of whether this works, the thing I really love about using this platform is just how easy it is to iterate. So if this isn't working, oh yeah, there we go. See, Edge Impulse was yelling at me, but I'm actually a master, right? Like I've got this totally under control. It was very sure that was a chop.
It's an art as well as a science.
It is. And I think that's like I said, the thing I've learned is that this is a very iterative approach, because during this process, if you built a model and you're trying it out and it's not doing what you want it to do, well, that's the point where, okay, I need to go back. I need to add some more data into my model so that I can build something stronger, more resilient, adapts to these situations a little better, and whatnot, so that you have a model that you're happy using. All right, let's get these side by side, because once you have your model built, or at least once you have it in a state that you want to actually try it out for real, because right now I've got this working, but the model is in Edge Impulse. It is not actually on my device. So I couldn't unplug my device and take it anywhere and use the model. To do that, I actually have to deploy it out to the Swan. To do that, in Edge Impulse, I can go to the Deployment tab, and you have to click the correct tab, Deployment tab, and you can see that you can basically export your model to a wide variety of different places, different boards, and whatnot. The Arduino option works really well, pretty simple for working with this. So I'm just going to do that and export it. You can choose between an optimized or an unoptimized model. The Swan, as I mentioned earlier, is pretty beefy, so you can actually get away with quite a bit. And Edge Impulse will tell you sort of the difference between the two models. In this case, it's pretty irrelevant because the model is quite small. So I'm just going to take whatever the default is. But I like using the Swan because sometimes when there is a difference here, and if something's going to be using a decent amount of RAM, you can get away with it on the Swan because it's got quite a bit of processing power. And what this gives me is a zip file. So I've got the zip file open, and it's got a folder. And all I need to do to actually use the model in my Arduino app over here is drag the folder. So I just grab the unzipped folder. I'm going to drop it in my live folder. And when I do that, I've got the model. Everything in here is what I need and ready to go. And in my tutorial, so I'll close this out and head back to the next step in the tutorial, which has some code that I can copy and paste to actually use this model, which I'm going to paste in, and then I'll discuss what this is doing in a moment. The one step you do need to take is by default, because you need a reference to the model itself in the live folder. So it wants this to point at this .h file that appears here. So I'm going to call this Excel testing inferencing.h, and we'll go ahead and upload that, and then we'll look at what this code actually does. So some of this can look overwhelming, but a lot of this is going to look fairly familiar. And I can say, as someone that helped build this example, a lot of this is fairly copy and paste friendly. If you want to build something like this yourself, you don't have to have some really in-depth, intricate knowledge of the innards of Arduino and C++ to make this happen. Because, for example, this code up here is the same code that was there earlier to just read the raw data off the accelerometer. It's really no different, other than Edge Impulse wants your data in this format called a signal, which you can find documented on their site. That's where we got this information from. Because the thing that's actually doing the real work here, the sort of core of this process, is this run classifier function. So this is the thing that's taking that signal, which is going to have data from the accelerometer in the format that Edge of Impulse wants it, and places it into a result. And then after that, this code is all just logging code. So this is, again, stuff that I hacked together that's basically just printing out things like how long the classification took, different labels, how confident is it that this was a chop, how confident is it that this was idle, and then finally the end prediction based off the gesture you did with a model. Here's what we think this actually is. And so once this is on the device, which looks like it's finishing up, we should be able to try this out. So that was successful. So we can bring up our serial monitor. And what we should see, there we go. So I was half moving it. So let me half moving again. All right, I'm going to start to do a chop. We'll see if it correctly can say chop, which it looks like it is. And then now I'm going to set it down. And if idle works, then I can say I successfully mastered machine learning. I don't think so, Paige, though. I think I'm setting it down like at a different angle or still moving it because my idle isn't quite working right.
Yeah, the accelerometer can be a little twitchy. I noticed that when I was building my own version, but as long as you've got it maybe taped to your board or in some other way stationary in the same position, that really helps to get the accuracy up.
Yeah, taping it to the board is a really good suggestion. I meant to do that, but I didn't think about it because otherwise you have too many planes it's moving on. But the cool thing to me is that I now have this model running on the Swan. So at this point, I could go cord free. Like this thing is, I could plug in a battery. I've got a battery over here, right? I plug in a LiPo battery that you can get off Adafruit or whatever into this no carrier F. And now I've got a wand that I can use completely on we're running completely off the Swan. I could plug it into battery power. I could tape everything down. I have a wand. I could put it in a package. I could start selling it. Kids everywhere would buy it and love it, and we'd be wildly successful. Because I think this process is really, really cool because the things you could build, like a lot of the Hackster projects that we showed, all basically can leverage this exact same approach for looking at accelerometer data or image data or a lot of the other data formats that Edge Impulse supports as well. So this is cool. But one thing that I want to add is I actually want to get some data out of this process. For example, I want to know like what gestures are people using, right? I need some analytics on my device out in the field. I want to keep track of these timing things, like how long is this process taking? I kind of want to keep tabs on that as well, because if all of a sudden my model's taking like seconds and seconds long to process, that's a sign that something's up. There's some issues. Maybe I want to report problems that are occurring, like error conditions, have some way of flagging that so that I'm aware of what's going on here. And for that, you can use the note card, right? We just looked at how the note card is a really appealing option for working with cellular data, which fits really, really nicely into this sort of model, because it's not only an easy means of getting your data from someplace like here up into the cloud, it also, because it's working off cellular, gonna work outside of Wi-Fi range. You could put these things in a vehicle. We have customers that use the note card not only to look for sort of MLE things like accelerometer data, but are also reporting on location because it's got a GPS. It's got a GPS module built into it as well, so it can track location as well as any sort of data you want to send up from a process like this. So to do that, actually, there's not much else I need to do. So like Paige did earlier, I would need to have a NoteHub account and a NoteHub project because the note card knows how to speak to NoteHub. It just needs to know what project to essentially dump its data into. So for this, I already built one somewhere down here. I'm very clever, so I called it the Magic Swand. You can see my device here is connected to it. And then I'm also going to need, so earlier when Paige showed off the note card, she was showing how to send commands to the note card just directly through a web browser. Well, we also have SDKs for communicating with the note card as well. So if you're working in a platform like Arduino and want to interface with a note card, that you can do so. So in this case, it's in the platform INI file. I've already got the Notecard listed here as a dependency, so I can pull in the Notecard SDK and start communicating with it. And from there, it is just another bit of data. So I'm going to do the same thing I did before, where I paste this in and get this working, and then we're going to circle back and look how this actually works. And because I copied and pasted this in, I have to type this one again, inferencing. And then I need the product from the project I'm going to paste this into. So I'm going to grab that and paste that in here. And then the last thing I'm going to do is make one change to make this continuous. US, and then we'll back up, look at how this works. So I'm going to upload. Now, what I changed here is, for the most part, this code sample is exactly the same as it was before. There's actually only 2 blocks of code that are new, other than the import. So I'm bringing in the Notecard SDK for working with Arduino. And then in my setup, I've got this new file here. Now, this is the same hub.setRequest that you saw Paige do earlier, where I'm associating the Notecard with a product. I'm setting it in continuous mode because continuous mode is just a way of maintaining a constant connection with NodeHub, which is very demo friendly if you want to see data right away. So I'm setting it in continuous mode. So this associates the Notecard that's sitting on my desk with that NodeHub cloud backend. And if I go down in my loop, so this is again all the same, other than after I do all my printing, I've got another chunk of code here that does a note.add request. Now, once again, this is the same command that you saw in the quick start earlier, but this time, instead of hard-coded data, we're going to grab the real data that's coming off of our machine. So our times, for keeping track of processing times, our prediction, and then how confident we are in the various different classifications that we have. And then we use the Notecard SDK to actually send that data up to the cloud. Now you see that this is already running. It's been plugging away. And so if I go to my NodeHub project and I go to the events list, you'll see that these things have already started streaming up to the cloud. So each of these events has this data. It actually has some additional metadata as well. So I have data on what's coming up. You see that my model is kind of busted, but that's not the point, because it's really not sure if I'm doing a chop or an idle animation, but it's going to predict a chop. But I'm getting this data coming up at a regular flow. I'm getting some metadata, like when this was captured. I could enable GPS. Right now, this is giving me the location of the nearest cell tower, but I could enable GPS so that I'm getting a very accurate location that is tied to this as well. And I've got this like live look at how my device and how my ML process is working. And I have it working over cellular. So now I could really just plug in a battery and take this. I could start, going off and chopping out in the field, start running across the road, and this thing is going to continue to work as well, which I think is really, really cool. And as one sort of bonus thing here as well, this data is cool, but you'll notice that on its own, it's not super useful because, I mean, even though you can see this, it's not like, who wants to look at a table like this with raw data? But remember that our goal with NodeHub is to help you route your data to wherever it is you want your data to be, your end destination to be, I guess you could say. And for routes, we can help you set up a large number of routes that are things that are built in. So we have built-in ways of sending to places like AWS, Azure, and a couple different other platforms as well. Or you could send it to just some general endpoint. So if you just wanted to set up a database, your own database that accepts this data, and you wanted to run your own sort of processing or analytics on it later, that's something that you could do as well. I'd especially encourage you to check out our routing tutorial, which is what I think this links to. Yeah, it does here, because we have some hands-on tutorials that walk you through quite literally every step you need to take on a bunch of different popular platforms. So that's worth checking out. And I followed one of our tutorials for talking to UbiDots. UbiDots is just a dashboarding platform. They make it really easy to accept data and just show it in a quick and dirty dashboard online. So I already enabled one of these, and you'll see that if I go to these events and I just pick one at random, if I go to the route log, you'll see that I've already been forwarding all this stuff all over to UbiDots as they come in. And if you've been wondering what the third tab I've had open this entire time is my browser, it is that UbiDots dashboard that's basically getting a live feed in from the device sitting on my desk. So chop, we'll see if we can get it very confident in a chop here. Yeah, there we go. So I do the chop. Of course, it shows idle. At least you can see this is live data. Oh, there we go. Okay, I'm chopping now. At least you can see that I'm getting a live data feed in, which I think is super, super cool, right? And you can apply this to all those other examples of projects that you saw us working, whether it's like a dashboard to watch your speed check. Imagine that you're using this, you fit some accelerometers to some industrial equipment, right? I have a series of 20 washing machines running, and I've detected a pattern that, hey, if the washing machine has a problem, it's gonna buzz in a certain way or bounce in a certain way. Well, I could build a dashboard where I'm getting a feed off all 20 of those devices, see which ones are problematic, problems over time. I could also, this keeps getting cooler. We have a tutorial on Twilio. So if you also wanted to send like alerts, right? If all you cared about, maybe you don't care to see a steady stream of data, maybe that's sort of overkill, but you want to know like, hey, if something goes wrong, I want to know about that specifically right away. But you can wire that up as well. So if you looked at our Twilio guide as just an example of how you can do this, but like I said, you can send off your data to any arbitrary endpoint. So the sky's the limit in terms of what you specifically want to build. So hopefully you can get a sense of just the sort of power of all these technologies coming together. So using Edge Impulse for the model part of this, so the iterative process of collecting data, building up models, getting it out to a device. And then the Blues part of having the Swan, a really powerful microcontroller for running these models. And then the Notecard, a really easy way to do the cellular communication so that you can send data back and forth from the device very easily as well. And you put all those things together, I think it's a really powerful combination. Cool. Hopefully other people do as well. I want to look if we have any questions, but first I do have one last thing, because this usually is sort of the end of the demo, the last thing we show, because I think it's kind of a cool moment, right? We saw everything working together. Everybody was happy. Everything's going really good. But we have a new feature available that makes this process, this sort of iterative approach, really, really cool. And it does take a few minutes, so I want to kick it off, and then I want to see if we have any questions that came in. So this is a feature that is actually new. It's not a part of the lab. So you see we're done. That was the very end of the lab. And this is a feature that's not actually on our documentation site as well. So you heard it here first. It'll probably be something we're announcing in the next handful of days. But we're adding the ability for you to update firmware of not only Notecards, but also your host microcontrollers as well. Now, why this is cool is it'll also allow you, in the context of Edge Impulse and Edge Impulse models, to remotely update the models that you're using on your host microcontrollers as well. So to put that in the context of our examples, suppose we release our toy, right? Everybody's out there doing chops, things are going amazingly, but what do you know? Somebody on our team says, you know what? I have a great idea. This is an absolutely amazing idea, and I'm going to call it. I'll switch over to here. I've developed this new gesture called a wave, right? Brand new. They're not going to know what hit them, right? But it's like, oh crap, we've already sold 3 million of these wands. The kids around the world are already using them. How are we going to get the wave gesture out to them? This is ridiculous, right? How are we going to do this? Well, Outboard DFU, or our ability to help you update firmware, can help with this, because essentially what you can do is you can build new versions of your firmware. You can register them in NoteHub. And then once they're registered, so you can see I have V1, this is my no wave version. And then I have V2, this is my version where I basically went into, before this, took this model from this second Edge Impulse application, built it up, and then I uploaded it into NoteHub. And what I can do is I can go to my device and I can select the host firmware. So the host being, in this case, the host that's running associated with the Notecard. So in this case, it'll be my Swan. And I can say I want to update my firmware, and I'm going to kick off an update for version 2. Now, what this is going to do is this is going to essentially queue up the change on the Notecard. Because again, remember, we're working over cellular. So it's not like this is going to flip a switch and immediately go live. Instead, what the Notecard is going to do, and I'm going to bring, I got to spell Google Chrome correctly. as a side note, why this is coming up, I'm using Firefox because I'm a big Firefox fan. So the reason you can't though connect to a note card in Firefox because Firefox does not support the web serial API, which is how the magic in here of connecting to a note card works.
Mhm.
It's kind of a shame, but I'm going to go in here and I'm going to connect to my note card. Same approach that Paige showed earlier. I do have to run one new command, and that is just basically a turn it on type of flag, right? So card.dfu, I have to enable it. This is what's going to make the note card actually sort of check every time it syncs. Hey, do I have new firmware that's available for my host? And if so, let me push this out. And I'm also going to, because that should, just doing that should essentially queue it up so that the next time it syncs, somewhere in here, we're going to see that it picks up on the note card firmware, or I'm sorry, on the new host firmware, and then port it over to the host. Now, one thing cool is that while this process happens, the note card never stops working. You can see it's still dutifully going around and it's doing, where was it? It's still adding notes, right? It's still working with the host. At some point, the host will go offline for a few seconds because it's when it actually gets its firmware updated. And you'll see that it's doing something, right? It looks like right now it's downloading the new firmware or over DFU. So it's like 30–40% done. And the one reason why we don't totally have this as a new feature is we're working on making this process a little bit smarter. So right now, what you're seeing happen is it's actually downloading an entire new .bin file. So the entire firmware that's running on the Swan, which is about 110K, something like that. Whereas we want to make the process a little bit smarter because the only thing that's changed in here is the model itself, which is not quite that large. So it could be smarter, it could be more efficient, but you're getting an early access here. So you're going to see the raw process work. And why don't we take, it looks like it's still doing its thing. Do we have any questions? We could probably real quick while we to this finish.
Yeah, definitely. And so we've got a couple of good ones that just came in. I think you answered this first one from AB about whether what happens if you flash and there's no code changes. Sounds like that's it'll just reflash the whole device.
Yeah, at the moment it's not smart. It's just going to do it again.
And then from Nico, is this just on the Swan MCU, or will it also work with other kind of compute CPUs attached?
There are some other boards that are being supported. That's still sort of one of the things that we're working on. So I don't have an exact list for you. I would say stay tuned. And I also should mention, since I have it up here, if you are curious about like Blues things, this newsletter that's on our dev home site. So if you want like news as to when we announce this, because I don't have a final list of boards, it will be more boards than just the Swan, but it's not like every board out there. It'll be just like a whitelisted list of boards that we support.
Got it. And then so from AB with the feature flag for enabling the DFU, is that something that, if you had maybe like a brownfield deployment already out there that you would, something you would need to say, hey, I'm planning to, do device firmware updates. I need this enabled before I ship it out, or is that something that you can dynamically change after deployment?
I'm not positive, but at the moment, I think you need to enable it beforehand. But I think the idea is that you would just set it up so that it was an option before you actually deployed those devices out. But yeah, I think it's something you would have to enable beforehand.
Got it. Awesome. And yeah, just a brief kind of comment from my side. Just yesterday, our CTO at our kind of Edge Impulse keynote brought this up on, think about your active learning loop, because, we have a lot of features in our platform that are, like TJ said, it's all based around an iterative approach. And this is exactly this is amazing for that sort of purpose. You can collect, say you have models out in the field and you're struggling with a particular environment or context, you can, with this type of technology, you can pull that data in over wireless, as TJ showed, retrain your model, and then redeploy it out. So this is really, really awesome to see. Really great.
And it looks like it just finished. So this was the last, once it got everything downloaded, it did the MD5 stuff, just making sure everything's in order. And then as soon as it did, you see that it powers the host back up. And this is like, because if you remember, this is in the setup process on the host, the hub.set, card DFU. And then when it starts back up, the next note.add has a wave that's part of it that wasn't there before. And so instantly, so not only can I just dynamically add that, but then it sort of funnels all the way up. So if I go to my events and I pop in here, you'll see my wave is not that one in here, automatically funneling up here as well. And then in UB dots, if you were skipping ahead, you might have noticed I already had a box in here to show it. So we'll see if I can actually, I don't know. I haven't practiced with this one as much. I don't know how Brandon waved, but we'll see if I can get a wave to show up at all. Oh, it thinks it's idle. So it's coming through in the data, but that doesn't, you're going to want to go to other workshops here to figure out how to build a model that works better than whatever garbage I just built. What I'm hoping I am impressing you with is just how cool it is to get the model out there, to get data off of it, to be able to update it on the fly. And hopefully this sort of outboard DFU can help you do this. And then you can go to other workshops for building better models.
Yeah.
Cool.
This is
oh
yeah.
Oh, it's sorry. I think all I had left, because I did promise people a discount code. I think the last things I wanted to mention is that if you are curious about any of this, we have, like I said, if you just Google Hackster Blues Wireless, that's, I think, your go-to bet for like project inspiration or the types of things that you can build. I'll remind you again that we have the contest, and this time I will actually throw it in the chat I don't know if I can send it to everybody, actually. I'll put it in here for hosts. So hopefully you can forward that to the whole group for the contest. And then the last thing I had is 15% off any starter kits if you use this code Imagine15. And then you can also go to this link. If you use the link, the code doesn't appear till like the checkout process, so it's a little bit weird. You don't see it till the very end, but I promise it will be there. And then I guess if you have any questions that come up that maybe you're watching the recording of this and you have some questions, our forum is the best place to go if you have anything, you think of any questions after this, you start building with some of these approaches and you have some questions, feel free to reach out there and let us know.